MEI Statistics Minor chi-squared tests 1.3 Goodness of Fit. When we're thinking about statistical models, what we do is we always start with raw data. So for instance, heights of students. We then try our very best to come up with some simplifying assumptions to turn this into a model. For instance, the normal distribution. Now, why do we want to use a model? Well, when we use raw data, we can only evaluate the behavior of a sample, or multiple samples, certainly not the whole population. And we choose models which we know everything about, so we can predict what the population may be doing, assuming that those assumptions are valid. So if we start with a small sample of data of student heights, we could produce lots of summary statistics, but they're all about the sample. We could draw a frequency diagram, but again, it's only about the sample. So if we wanted to predict for a randomly chosen student what is the probability that H is greater than 180, our only estimate here is that we've got 1 of our 12 over that height, so is it equal to 1/12? That assumes the population is distributed exactly as the sample is. What about the probability that H is less than 159? If we use the sample, we would say it's 0. Now the current form of that histogram isn't very useful. We can't see much to do with the distribution. So you might draw a more advanced histogram by grouping the data. And my statistical eye can see a bit of a bell curve in there. We could model it using a normal distribution. We'd still be using the summary statistics to predict the population statistics, but this is far more likely that the population roughly follows a normal distribution than it is exactly the same as the sample. Now what would we say the probability that H is less than 159? According to my calculator, it's 0.0585, a lot more realistic than 0. The question is, how can we decide whether our model is suitable for the data? I simply did it visually, a little bit GCSE really. So at A-level we use a goodness of fit test. In these tests we'll see how well a chosen model fits the observed data. If our simplifying assumptions are justified, we should find the model's a good fit. We will compare the observed data with the expected frequencies predicted by the model. Now I use the normal distribution as an example. A problem with this is that I'll get a different goodness of fit decision based on which categories I choose. So here, with a class width of 10, it might come up with a different decision as to whether it's a good fit if I'd used a class width of 6. So U will only be examined on goodness of fit of discrete distributions to get around this problem. Now there are many different statistical techniques for testing goodness of fit. You will be using the chi-squared method. In our next video, we will be looking at the chi-squared test for goodness of fit.